So you have your speed versus time graph. Speed time graph. So I'm accelerating. You go at a constant speed, and I accelerate again. Yes? We pose the question. Oh, you can do it otherwise, it's the same. If you do speed up and then time downwards, it's all the same.
Wait, but it isn't. It isn't. Because the X varies the one down. It doesn't matter this one.
If you have X and Y, it doesn't matter where you place Y. You're accustomed to see X, Y, but you can't do X, Y. You're accustomed to see it in a way, but you can switch it up. For example, you're accustomed to seeing the number 4, but I can write the number 4 as 2 to the power of 2 as well. Time, speed, time. So, you're driving at a certain speed, or let's put it the way you guys learned it best. Let's place time there. Speed there. You are in your car. As soon as you reach New Haven, your parent presses on that pedestal and your speed increases exponentially and you love it. Yes, Need for Speed. We all have played that game. Need for Speed. Gran Turismo. Everyone has played that game. So, the question is, you can calculate the average speed. Let's say here is 7 a.m. and there is 7:15. As you notice, the speed changes every time. But what if you were traveling at a constant speed? If we do as if you were traveling at a constant speed, what would that speed be? That's the question. Because you have the variable. You're going here a different speed, here different speed, here different speed, here different speed. What if you were driving at a constant speed? What were to be that constant speed? Yes, do as if. And then you do something that is called. We're going to the book afterwards. I'm going to do something that's not in the book. Then we get to the book. Because the book, I find that explanation not at your level. It's called the derivative. The derivative. As soon as we start with the next book, or you go to Cape, you deal with this immediately. What is the derivative? The derivative states, if fx is ax to the end, the derivative function, or f accent, f apostrophe, is n times a multiplied by x to the power of n minus 1. Wow. Welcome to Cape. This is the first two sentences of mathematics. So, if I have a function that says 3x to the power of 4, what would be my derivative function? F apostrophe. That would be 4 times 3 x 4 minus 1, and you just simplify it, which in turn becomes 12x to the power of 3. That's it. Yes, this one is simple. As we progress, the CSEC one is simple. When we go to additional mathematics, okay, you will get one that will fill your entire sheet. Yes, time speed. Yes, this is time speed. Time speed. Yes, so I'm traveling at a specific distance. Specific speed. And as you can see, my speed is not constant. It's not a constant speed. I increase and I slow down and increase again. What if I was traveling at a constant speed? What would have been my average speed? Yes, that's what I'm looking for. What would have been my average speed? Yes, CSI and so forth use this method a lot. If you see someone escape from prison, they calculate, okay, what is his average speed? So I'm going to take this radius, so he's around this area, looking at his average speed. Yes? You use that. It's just the derivative function. CSI and so forth, they use this method. So, let's go again. You have a function. Y equals 3x squared. Yes? 3x squared. Find the speed, find the average speed at where this person was going at x is 4. Yes, so you have a graph, 3x squared. Here it is. Whoops. Yes, something like that. When x is 3, what is his average speed when x is 3? So how do you find it? Well, find the derivative function. Y apostrophe is 6x. And then, what is x? X is 4. So, its average speed at x is 4 was 24 meters per second, whatever the unit is stated. That is the easiest and simplest way, by remembering the formula. Sorry? No, this is the question. What is the average speed when x is 4? It asks you that question. So you find the derivative first, and then it's 6x. So multiply with the question.
So do we get both the x and y if we get when we're trying to figure out the average speed?
No, you only want to know the y. Again, you have a function. Normally it's never drawn. They always give it to you. There it is. This is your function. Is 6x squared. I would like to know the speed, the average speed at x is 5. What more or less was the average speed at x is 5? First step, derivative function is the first step. And derivative function is 2 times 6 times x 2 to the power minus 1. And that just becomes 12x. That's the derivative function. But where did I want to know the average speed? X is 5. So, what was the average speed at x is 5? Oh, 12 times 5. So the answer is 60. That was my average speed at x is 5. No, in this particular case, no. Normally you get kilometers and so forth. Now let's go the way the book teaches it to you. All right. Same example. Here it is. We'll take example 10, and then we shall do it exactly the same way. And you see, the way CAPE does it or the digital mathematics does it, you finish in 2 seconds. But you can't do it this way. It is fine. You have the function, what is it? X squared. Yes? They would like to know the gradient or average speed. You decide. Average speed or gradient where? At x is 2. So you have your function, x squared. They would like to know the gradient, average speed, when x is 2. So what do? They draw a tangent. What is a tangent? A tangent is a straight line that touches the function x squared in only one place. Where does it touch it? X is 2. That's where it touches it. The tangent. And if you notice this correctly, how do you find the gradient of a linear equation? y2, and this looks pretty much like a linear equation. So that's how they find it. They use the formula of a linear equation to find the tangent. Or you can use Pythagoras theorem as well to find the tangent. The gradient. 3 different ways. The one I taught you and 2 of the book. So, the answer is 4, right? Let's just look at the answer. The answer is 4. All right. Let's go at it. My function is what? X squared. What is my derivative function? 2x. Where do I want to know the speed at? X is what?
No, x is 2.
X is 2. So, what is my average speed?
2 times.
And what is the answer? So you decide which method you want to use. They're all the same. You get to the same answer. It's just that this one is a more advanced method, which I think is the easier method. You only have to remember a specific small formula and you get to the answer immediately. You don't have to draw linear equation y equals mx. If you want to do that, it's also fine. So, let's make this one. Draw x squared, only in the positive side. So in your notebook, x squared from 0 to 4. Y equals x squared. Draw the table from 0 to 4. Zero to 4. At 0, x squared is 0. 0 squared is 0. 1 squared, 1, 2 squared, 4, 3 squared, 9, 4 squared, 16. Yes? Now you have to draw it. Can I change it without disturbing? Let's see. There we go. Right? And for 19, so I'll use tables of 2. So I'll use 2. 6, 8. Since I only need between 2 and 3. At 0, it's 0. At 1, it's 1. Two, it's 4. 3, it's 9. And 4, it's 16, which is all the way 14, 16, should be here. Remember, it's not a straight line. Right. It's horrible. Let's do it like this. That's impossible. Yes. Something like that. Yes, it's a curve, as you can see, it's a curve. Yes, we all have it? All right, time to draw the tangent. The tangent only has to touch the function y equals x squared only at x equals 2. So take your ruler it only has to touch where x is 2. And you draw a line. X is 2. X is 2. Only there. Should only touch it there. X is 2. Start from 1 and end at 4. No, 1.5, 2, 3.5. 1.5 to 3.5. One and a half to 3.5. Should have something like this. More or less, of course. Yes? You can draw it longer actually, if you want to. Like this. But we will only take 1.5 to 3.5. You can do it longer if you want to, it's fine. 1.5 to 3.5. Yes, the tangent line. So I have a straight line. How do I find the gradient? How do I find the gradient? There's your straight line. The gradient is y2 minus y1 divided by x2 minus x1. Yes? So, choose your x1, choose your y2, and then make it. No, you need two coordinates. Choose two coordinates. You decide. The gradient will be 2 anyway. Doesn't matter which coordinates you choose. I will take, let me see, I take in 1.5. It's 2, if I'm not mistaken. No, something lower. It's something lower than 1.5. Gradient of a straight line. You need two coordinates to find the gradient of a line. You choose the coordinates. It doesn't matter. One is, for example, this looks like 4, 3.5, maybe 9. It's also 9. Three and a half, 9. That's one coordinate. What's another coordinate? It's not going to be 100%. 1.5, 2. Sorry? Three and a half, 9, 1.5.
So we have to like choose 12 coordinates from the equation, and so it could be.
Yes, that's chapter 9. Guys, chapter 9. Linear equations. Linear equations. This is chapter 9. It's not something new. Find the gradient of a straight line. We are not doing something new that you've never seen before. My drawing isn't 100%, so it's not going to be 100%. But just so you know what you need to do. Yes? My drawing isn't 100%. If I do it using this, yes, 1 to 4, this, right, is to x. This should be your tangent line. Oh. Oh. This. Your tangent line should look like that. Yes? Your tangent line should look like this. And then you choose two coordinates. Choose any two coordinates. It's up to you. Any two. Right? And when you do it correctly, your answer should be as close as possible to 2. Sorry? Because that's what they ask. X is 2.
As close as possible to 2.
Yeah, because it's not going to be exact. It's going to be precise.
So what if it's over?
Yes.
So Theo, what if
Here in the book, of course, it's a book, so they measured it to the decimal, but you are not going to see it to the exact decimal. Yes, you might get 2.3, you might get 1.7. Yes, you're not going to get it exact.
Theo, what if we get like over? So I calculate mine, I get 3.6.
No, there was something wrong with the tangent line. Yes, that is why I do not recommend this method. I don't like it. It's not, if you're not really precise, it's not going to be precise. So that's my problem with this way.
Theo, when we make the tangent line, does it always have to start at a certain point?
It gives you, it says tangent at x is 2. Because you want to know the gradient at x is 2. So your line has to touch only 2. If it says x is 3, then your line has to touch 3.
But when we draw the line, can we start drawing that line to wherever we need to go?
As long as it touches x is 2.
That sounds very complicated.
What I understand is, can you start the line anywhere? Yes, I can start here and then this. That's what I understood. You don't have to start at 2, draw there and then draw there.
Yeah.
As long as it goes through 2, it's a straight line.
No, because I started at 1. And from the example, I didn't even start at 1. I started like in between 1 and 2.
Oh, it has to touch 2. You see? It touches 2, exact.
It can start from anywhere.
You can start from anywhere as long as it touches x equals 2. You want to know the average speed at x equals 2. So your tangent line has to touch where? 2. So you draw a line that touches 2, which is a straight line. Your line cannot do something like this. It has to go through 2 and upwards. Yes? You cannot do something downwards. No.
Drawing and I got an entirely different answer.
It has to be something like this. Like this. Yeah? Yeah, you have it, for example, like this. It's going more towards 1. You need more towards 2.
Well, this would be like even.
Yes, it has to be on the same line, parallel to 2. Yes? But of course, no, you're not going to get it exact.
find out the y, what do I do? 2 times x or
You
x
do the
squared?
drawing that he told you to do.
To find the y? What do you mean find the y?
To find the y, like you did one,
Mm-hmm.
no, 1, 4, 9, 16.
Mm-hmm.
But I did it square. So no, basically I did like to find out y. For example, this one you have to do x squared.
Mm-hmm. The 0, Then 1 square is 1. This is 1.
Oh, I see what I did.
2 squared is 4.
Oh,
3 squared is 9. You have them switched. You have x beneath and y above.
Is there questions in the, let's say, the CSAT test that forces me to use this drawing one and not the one, the short formula person?
No.
No? They never force me to pick one, then the other. Okay, that's good.
Yes? So, to go at it one more time, if this line at axis 2 is like this, your tangent line has to also be in the same direction, like this. Yes? So you have to look closely, more or less, how is the line going? So you have to do it like that. Because it's going like this, and you want to know here. So if you zoom here in, how is the line going? It's going like this. So that's how your tangent line should be going. Yes? It's an estimate. It's an average. It's an estimate. Your line has to be going at the same way, yes, the same way as this one is going. The same way.
Theo, when we try to figure out the rate of can we also use the coordinates at 2 and 4 as well?
2 and 4, it has to be on the tangent line. If it's on the tangent line, you can use it.
And the tangent of the line is also on like 2 and 4.
Mm-hmm.
You can also use that to your advantage.
If it's on the line. The last way of doing it is using Pythagoras theorem. Pythagoras theorem.
So do you just grab that 2 and 4?
Teacher, is this a better line?
Yes, it's a better line. Yeah. This is 7.8 with 2 is 6 divided by 2. Your answer is gonna be somewhere about 2.3, 2.4, but as I said, it's not gonna be precise. Yes, it's not gonna be precise. Yes, it's not gonna be precise. So that's why I let you use this formula.
I'm pretty sure you have to start with X.
You place the x value in the derivative function. Let's do one more. So
so it's basically supposed to touch x when x is 2, right?
Yes, correct there. You want to use my formula or the formula that I taught you guys? The derivative function? The what? Yeah? So you have 4. Look at exercise 4. That is the graph. 6x minus x squared. Right? Find the gradient at x is 1. X is 1. I need x is 1. What's the formula? Y equals minus x squared. The one I taught you guys, as you saw, was only x squared. But what if you have 2? The same rule applies. Which rule? What is the n of 6x? It's to the power of what? This is to the power of? The power of 1. So, let's just write 1. Power of 1, right? All right. So, 1 times 6 x 1 minus 1. No, it's always minus 1. Subtract what? 2 times x 2 minus 1. Always minus 1. So, what is the final answer? 1 times 6 is 6. What is x? 1 minus 1 to the power of 1 minus 1. What is the answer? X to the power of 0. And x to the power of 0 is what? No. 1. So technically it's written 6 times 1. That's what's written there. X 6 times 1. And 6 times 1 is 6. So the derivative of 6x is 6. Yes. Minus 2x. That's the derivative function. You keep applying the same rule. You have to know your exponents extremely well. X to the power of 0 is 1. So the derivative function is 6 minus 2x. They would like to know the gradient where at x is 1. So your answer, what is your answer? When f apostrophe is 1, 6 times answer, oops, it's minus. The tangent is 4. Yes? There is no need for drawing, no lines, nothing is needed. As long as you know the formula, you can find the tangent at any point. Mm-hmm. 2x. Subtract by 1 power, yes. All right. This is a special exercise at CAPE on itself. This exercise, derivative function, it's an exercise on itself. You get a few functions and you need to find the derivative, only the derivative function. So I'm going to give you 2. See if you can find the derivative function. Find both at x is 2. Here is 1. Find the derivative function at x is 2 for these two functions. Yes. This is derivative. This is the original. This is the derivative. Sorry? The answer is A. Yes. Yeah, this is the same. The same. X is 2. Then you have to sit up front. Hmm?